Okay, let's wrap this up. This is going to be chapter 12.2, Intro to Logarithms. This video will cover our next 2 lessons. So remember last lesson we talked about exponentials. An exponential is a function where the variable is a power. If the variable is a power, you get exponentials. This one would be exponential growth. It would look like this. There's another way to write exponentials, and that's in what's called logarithm form. So here is something in exponential form. In exponential form, we would say 3 to the 4th is 243. In logarithm form, which you just call logs for short, that flips to log base 3 of 243 equals 4. Now I'll go through a lot of examples of this to try to explain what this is and where it's coming from. But this is the converting between the two forms. So let's talk about just what a logarithm is for a second. Logs are exponents. I mean that literally, okay? The equal sign means is. If you look at this exponential over here, the exponent was 4, and here the logarithm was equal to the exponent. So the logarithm is 4 because the logs are the exponents. So whenever you convert to logarithm form, the number out here by itself, the number on the opposite side of the equal sign, will actually be the exponent from your exponential form. Okay, so logs are exponents. Logs are functions. Each input goes to exactly one output. If I wanted to find the log base 4 of 16, that would just be 2. Now again, I know this is kind of nonsense to you, so let me just break this down for a little bit. Logarithms have a few pieces to them. They have a base. The base will always match whatever the power was, the base of the exponential. So say that I had 2 to the 3rd equals 8. Well, the base of this is 2. The exponent of this is 3. So when I convert this into log form, I have a log with a base of 2 because the base was 2. And remember how I said that logs are exponents? That means it's always going to be equal to the exponent. So it's going to be equal to the 3 over here. And this 8 goes inside the function input slot. Log base 2 of 8 equals 3 is how that's read. Log base 2 of 8 is 3. That's how you would read that. So this isn't log base 2 times 8. These aren't multiplying. They're just, it's a function. It's an input of a function. So let me do lots of conversions to kind of practice this. If 3 to the 5th is 243, which it is, so I was wrong up here. 3 to the 4th is 81. Oh well. Let's skip the 3's for a while. 2 to the 5th is 32. That's an exponent form. In log form, that would be log base 2 of 32 equals 5. 10 to the 3rd is 1,000. In log form, that would be log base 10 of 1,000 equals 3. Remember this one. We're going to come back to it. I'm converting between two forms of the same relationship. It's true that 2 to the 5th is 32, and it's true that log base 2 of 32 is 5. They're the same relationship. All we'll be doing for this unit is converting. Let's go the other direction. Let's say I was given a log first. Log base 4 of 64 equals 3. Well, for this, I do what's called the circle thing. Actually, sometimes I call it the heart thing. I'm going to go from 4. I start at 4. 4 to the 3rd equals 64. And it kind of looks like a heart. 4 to the 3rd equals 64. Another one. Log base 2 of 16 is 4. because 2 to the 4th equals 16. Okay, think about this one on your own. Try this one on your own. Log base 6 of 36 equals 2. How does that convert? 6 to the 2nd equals 36, because that is true. Okay, so that's converting between forms. The base of the exponent becomes the base of your log. The exponent itself becomes by itself on the equal sign. Whatever number is left goes inside with that log. What logs attempt to do is answer difficult questions, okay? 2 to the x equals 12. Well, there's no power, no whole number power of x such that 2 to the x equals 12. We know 2 to the 3rd is 8, and we know 2 to the 4th is 16. So 2 to something between 3 and 4 must equal 12, but I'm not sure what that number is. So 2 to the x equals 12 I can't really solve, because having this power up here as a variable, having the variable up there as a power, I can't like divide by x and do anything with this. But if I can convert log base 2 of 12 equals x, that gets the variable by itself. And that's good. That means we've kind of solved. There's a way to figure out what log base 2 of 12 is. We're not going to worry about that right now. Okay, so what I want you to work on now is evaluating. Fill in the blanks for these. Here's how you do that. Remember the circle thing or the hard thing. This is saying 4 to what power equals 16. 4 to what power is 16? The power is 2. 3 to what power equals 9? 3 to what power equals 9? The power is again 2. 2 to what power equals a quarter? Now you have to remember negative powers. 2 to the negative 2nd is a quarter. So the power is negative 2. To answer a logarithm, to evaluate a log like this, you ask yourself the question, the base to what power equals that other number, a quarter? There's two special types of logarithms. One is called the common log. If ever you see a log written without a base, it really just means you have a base of 10. Okay, so we use base 10 so often that we don't bother writing it down here. If you just see log of 1,000 equals 3, that means your base was 10, because 10 to the 3rd equals 1,000. So in the same way, the log of 100 is 2, and the log of this number, 1,000,000, is 6, because there's 6 zeros. 10 to the 6 equals 1,000,000. There's also one called the natural log. This one is going to feel super different and foreign. It's not at all different. The natural log, we write with ln. ln just means you have a base of e. This is the same as having log base e of 25. So you could convert this into e to the x equals 25. If ever you have a log with a base of e, we call it a natural log. You'll see that ln for natural log. That'll come up in your homework just a little bit, but not a ton. So don't worry about it too much. Okay, so I think all I want to do is just get more practice with this, more familiarity, and we'll be okay. So let's get some weird ones. Let's say that I had the log base 3 of 1 over 9. If this is a number bigger than 1, and this is a number less than 1, the solution to this will always be negative. 3 to the negative 2 equals 1/9. Because 3 to the negative 2 becomes 1 over 3 squared, which is 1 over 9. And say that I had like log of 64, log base 64 of 8. And I want to see what this equals. So the question is 64 to what power equals 8? Well, that's a tough one. 64 to what power equals 8? 8 is the square root of 64. And you might remember that if the power is a half, that's a square root. So the answer here is going to be a half. 64 to the 1/2 equals 8. Last one. Okay, two more. Let's say we had the log of 10 to the 3rd. We'll just say it equals x to have a variable there to point to. This has a base of 10. Something really cool happens. If the base matches that number there, they cancel each other. The answer to this is just going to be 3. Because it's really saying 10 to what power equals 10 to the 3rd? The answer is 3. So if you have like the natural log of e to the 5th and you want to know what that equals, well, the base here is e. If you have ln, the base is e. So it's like we have this. E to what power is e to the 5th? The power is 5. So that's a whole lot of just converting and evaluating with logarithms. And you probably right now feel like you don't even understand what logs are. That's okay. That'll make sense as you move further along in math. Right now, we're just trying to introduce the idea of how to convert between them. If you have questions, holler at me. Otherwise, peace.